So if you want to follow along with this, you're going to want to go to your grade book and pull up your test so that you can see what the problems were. Number 1 on the test was just to give you access to Desmos so that you would have your calculator. Number 2, ask you to find the sign of 3 pi over 7. You should recognize that if it has pi in it, it's a radian. So if I pull up my calculator, I want to make sure that it's in radians. I think some of you did not change the mode. So I'm just going to type in the sign of 3 pi over 7, and I get 0.975 if I round. So that's where that one came from. So let's see, let's go to the next one. So the next problem was a word problem. It was number 3, so if you're reading along. It says that a car wheel has a 16-inch radius. So I always draw these out so I can see what I've got. You know, if I end up with a circle and an angle in the middle, I know that I'm going to use my formula that I've been working on. So this is the distance, this is the radius, and this is theta, the angle in radians. It says through what angle to the nearest tenth of a degree, so it's asking about the angle, does the wheel turn when the car rolls forward 2 feet? Since 16's in inches, I'm going to put this one in inches. I can just plug everything into my formula. The problem is that this formula gives an answer that is in radians always. The problem asked me to do degrees, so I need to change this to degrees, and in order to change radians to degrees, I multiply by 180 over pi. So that is why on this one I end up with 85.9 degrees. So that's this one. Okay, let's see the next one. So number 4. Number 4 asks you the complement of pi over 4. Complement means they add up to 90 degrees, or they add up to pi over 2, either one of those. So I need to figure out what I can add to pi over 4 to get 90. So I could change pi over 4 to 45 and say 90 minus 45 is 45 degrees. Didn't actually ask you what to give it to me in radians or degrees. I counted either one. Or I could do pi over 2 minus pi over 4. Would take some subtraction with fractions. So 2 goes into 4 2 times. 2 times pi is 2. So I have 2 pi minus 1 pi, which is 3 pi over 4. So that's what it would be if it were in oh wait, sorry, 2 pi minus 1 pi is not 3. I'll keep looking at that, trying to figure out what I did wrong. That would be pi over 4. Okay, so your 5th one is a word problem. Let's go to that one. Make sure that you're following along. Number 5, another one with a wheel. The rear wheel of a lawn tractor has a 10-inch radius. So again, draw it out. Let's see what we got. Find the angle in radians. So this time it's asking for radians, through which a wheel rotates in 30 seconds. So if the tractor is traveling at a speed of 9 miles per hour. Now 9 miles per hour is what we are used to. It's how much we would be traveling down the road. So that is a linear speed. So it's telling you how far it traveled, and it traveled 9 miles. So if I take this one and I write down what I have 9 miles, and I know that we've gone for 1 hour. I can't really use that right now because all that tells me is the linear speed and the time. So I could use this in my formula that I have, my S equals R theta, to get the angle, because I know that I've gone 9 miles. I know that I have a radius of 10 inches, but I can't mix miles and inches. So I'm going to have to do some conversions to get that theta. So let's see. I have 9 miles. What do I know about inches? I know that there are 12 inches in 1 foot. That takes care of the inches. I know that there are 5,280 feet in 1 mile. That takes care of the feet. That takes care of the miles. Every single thing has canceled out. When every single thing cancels out like that, it tells you that this is radians. So this is 57024 radians. But the thing is those are radians per hour, because that's how it gave it to us. It gave it to us an hour. And we want seconds, and we know that 1 hour is the same thing as 3,600 seconds. So now I know how much I have per second, which is 15.84. And we want to know how much it is per 30 seconds. So just multiply by 30, and I get 475.2. That's how we get the answer to that one. Let's see, number 6. Another word problem. And sometimes your numbers may be different because I've set it to generate different numbers for different problems. This one says a bicycle wheel rotates 9.5 times in 9.3 minutes. So 9.5 times in 9.3 minutes. So we have to decide what this is. On the last problem, that was miles per hour, so that was linear speed. Anytime we're given something about how many times something goes around a circle over in a period of time, we're given angular velocity. The thing is that usually angular velocity is in radians. We have rotations. So this is 9.5 rotations, and it's in 9.3 minutes. This problem is asking for degrees, so you have to know that 1 rotation is equal to 360 degrees. So we do our math. 9.5 times 360. We could divide by 9.3 and get minutes, but we want it in seconds. So 1 minute is 60 seconds. Do my math and it tells me 57 degrees, but that's per second, and we want it for 4.7 seconds. So that is how we get to 67.90 degrees. So that is number 6. Let's see. Number 7 is the exact same problem that you had on a quiz. So it would be probably a really good idea for you to use your quizzes to study. It gives you a distance, which is 10 yards, a radius 11 yards, asking for the angle. So again, you have the same formula. We have a distance, we have a radius, divide by 11, and you get 10 over 11. It's already reduced. It comes out in radians because they always come out in radians. Pi is not radian. Pi is just a number. That's not the symbol for radian. So you don't need to put a pi in there every time you do these problems. Number 8 says to change negative 45 degrees to radians. In order to change degrees to radians, you multiply by pi over 180. So when I do my math, I get negative pi over 4. Number 9, same thing, only it's degrees to radians. So we multiply that by let's see, pi over 180 again. And when I do my math, I end up with 49 pi over 18. You need to get yourself a good calculator that will reduce fractions, because we're looking for accurate answers in a trig class where you're going to be doing calculus later. 10 asks for the supplement. The supplement of pi over 4, you're going to take 180 and subtract the pi over 4. So 180 minus pi over 4 comes out to 3 pi over 4, or you could do 180 minus 45 degrees. Number 11, let's see, is another word problem. It was multiple choice. It gives us a wheel rotating 70 times in 1 minute. So it's going around those 70 times, which means it's angular velocity because it's giving us a spin here. Through how many degrees does it turn in seconds? So 1 time around is 360 degrees. So we need to know that 1 time is 360 degrees. We also need to know, so we're doing 70 rotations. I'm going to write rotation there so that I know. So one rotation is 360 degrees. I don't want it in minutes. I want it in seconds. So you would go through and do that. You have 1 minute is 60 seconds. That gives you 420 degrees for 1 second because everything cancels. You want it for 11 seconds. So 420 times 11 is 4620. Let's see, number 12. Number 12 is another word problem. Another one that we had a few minutes ago. It's the exact same problem. It's just multiple choice now. So you could go back and do that one. It's the one with the 16-inch radius. It has 16-inch radius and goes forward 2 feet or 24 inches. So that one was multiple choice. Is the exact same problem we just had. So 85.9 degrees. Number 13. Number 13 is a wheel with a 40-inch radius. So here we go, 40 inches here. Radius, remember, is just the center to the end. So when it says that the radius is marked in 2 points, we could draw this anywhere. We just need to know that the distance between the 2 points is 19 inches. So now that should look familiar to you. We're asking for the angle, so this fits with our formula that we have. This is the exact drawing that we have for this. So all we have to do is the math. So theta is going to be 19 divided by 40, which comes out to 0.475. Again, this is always radians. The problem is asking for degrees. So in order to change this to degrees, we multiply by 180 over pi, and we get approximately 27.2 degrees. Let's see. 14 is the complement of 86, so 90 minus 86 is 4. 15, the supplement of 78.15 is 180 minus 78.15 is 101.85. 16, pi over 4 on a unit circle. Hopefully you had your unit circle as part of your notes. If you're looking at your unit circle, and pi over 4 is in that first quadrant, you should easily be able to find it. It's 45 degrees. 17, 7 pi over 4 might have been a little harder for you, but you can always change that to degrees and find it a little easier. So that one happens to be in the fourth quadrant. Let's see, number 18 wants you to find something that's coterminal to pi over 5. So coterminal means in the exact same spot. So if I'm looking at this spot on the circle and I go around the circle 360 degrees or 2 pi, I'm in the same spot, but I've increased my degrees. So I would be adding 2 pi to this one. So if I use fractions, 5 into 5 goes once. 1 into 5 goes 5. So 5 times 2 is 10 pi. So that's how we get on that one 11 pi over 5. That's adding 2 pi. If we were subtracting, we would get negative 9 pi over 5 because this would just be a minus to get the subtraction. 19, change negative pi over 3 to degrees. In order to change something to degrees, you do 180 over pi. So this would be negative 60 degrees. And then the last one, this one tripped some of you up. The last one was a true-false one. It wanted to know if 185 and negative 545 were coterminal. If I add 360 to that, I do get 545, but it's positive. So that doesn't give me negative 545. If I subtract 360, if I keep doing that, eventually I get negative 535. I'm never going to hit on negative 545, so they are not coterminal. They have to be in the same spot on the circle in order to be coterminal.